everyone, a very good afternoon to all of you. I am Twinkle, welcoming you all on behalf of Solar Quarter and First View Group to our today's webinar on Energy Storage Market Outlook 2022 Sri Lanka. Hope you had a good time networking with your peers today. We'll have those sessions again at the end of the session. With this current scenario of economic crisis in Sri Lanka, we just hope that everything gets back to normal as soon as possible. Also, I'd like to thank all the panelists and attendees who could make it today to this webinar. Maybe solar is the solution for the power crisis now. Now it's time to start on with our webinar, but before that, I take the pleasure to thank our partners, Goodwe and JA Solar, for extending their immense support to organize this event. Now, can I request my team to start playing the sponsor video?
Hello everyone, Namaste. Myself Divyang Patel from Seven Solar Energy based at Morbi, Gujarat. Seven Solar Energy is a company specializing in advanced technological ground mounted solar plant. We have recently completed Gujarat's first 2 megawatt captive solar plant in a solar policy of 2021. We have developed single axis tracker structure with a bifacial module of 495 watt peak capacity, and we have used 8 pieces of Goodwe inverters of 250 kilowatt, which is first time in a Gujarat in our project. We have used power line communication system for data monitoring of the project and along with the PID recovery features, which is highly robust technology in Goodwe inverters. We are very satisfied with the newly launched product of Goodwe inverters, which we have used in our plant, and hats off to the service team. We didn't face any issue along with the project. The Goodwe inverters which we have used in our project are the only inverters which are best for bifacial facility gain sustainability and peak performance generation. The plant is able to achieve 8,500 units per day per megawatt. As a technical aspect, the DC to AC ratio is 1:1 for our project. I wish entire India team of the Goodwe all the best. Thank you.
Hi, I'm technical support engineer in Goodwe, India. Today we are at 7 solar plant where the plant capacity is 2 megawatt with single axis tracker system. We have used 8 number of 250 kilowatt inverter. This 250 kilowatt inverter has been designed for utility scale and with the help of features like PLCC, NTPID, AFCI and high current per MPPT.
thank you for the video. And now, without any delay, let's begin with a sponsor presentation by Mr. Eric Yang from Goodwe. I welcome Mr. Eric on screen.
This is Eric from Goodwill Solar Academy's
Yes,
Storage
sir.
Solution Department, and today I will give you a brief introduction of Goodwill Residential Energy Storage Solution. So let's start from the introduction of Goodwill. I think from the video we have many projects in India and in Sri Lanka. So Goodwill, this is Goodwill vision and mission. Our vision is create a new era of smart energy, and our mission is we are determined to be the main driving force in the global energy transition, create a sustainable future for us, for mankind, and for future generations. And we have installed 3 million units. We have this is the total our inverter have installed all over the world, and the annual power generator is 56 and 1,415 gigawatt hour. Okay, and this is our milestones, and we have Goodwill have established in 2010, and we have this is our milestones, and we have listed on Shanghai Stock Exchange as stock in 2020. And this is our global presence. We have our branches and the sales service centers. Also, we have our RD centers all over the world. And here is some global partners such as Aquarius, One Stop Warehouse, and the IBC Solar, Panasonic. We are the partners. This is our Goodwill Award. I think we have get most of the awards that we can get, such as the Red Dot Design and the UPD Top Brand. Also, we have in the SPI test, our storage inverter EH series and the ET series, we have a good result in SPI test. Sorry. And here is our global installation. We have installed 38 gigawatts all over the world, and we have our residential inverter, commercial and industrial inverter. Also, we have the energy storage inverter. And today the topic is about the energy storage inverter. So next round, I will give you a brief introduction of Goodwill storage inverter solution. And we have our per sales service and after sales service all over the world. So it is very convenient for the customer using Goodwill inverter have our per sales and after sales service. And this is our product map of the storage inverter. We have the DC couple inverter and AC couple inverter. For example, the range is from 3 kilowatt to 10 kilowatt for the hybrid inverter, or in some countries we call it the DC couple inverter. Also, we have included the single phase and the 3-phase. And you can connect your low voltage battery. The rated voltage is 48. And also you can connect your high voltage battery, maybe 200 or 300 volts. And also, Goodwill have the AC coupled solutions such as SBP, BH, and BT series. We also have both single phase and 3-phase inverter. And this is our battery, Goodwill battery family. So Goodwill is not only a storage inverter manufacturer, but also we have produced our own battery, both low voltage and high voltage. And we have our Circuit A series and the Links U series for the low voltage battery, and we can parallel connection it the maxima is 6 pieces. So the single union is 5.4 kilowatt hour. And it can connect to such as the ES, EM, and other storage inverter of the low voltage. And we also have developed the high voltage battery, Lynx F series and the Lynx S series. So this high voltage battery can connect to such as the ET series and the BT series. And here is the diagram of Goodwill storage. The hybrid inverter. You can connect the PV panels and the links the battery. Also, we have two AC output. The one AC output you can connect to the grid, and the other AC output you can connect to the backup load. And the working logic is the PV power will support the load first. If the PV power has the rest, it will charge the battery. Also, it can feed to the grid if it is available. And the load consumption priority is from the PV first, then the second priority is the battery. And if during nighttime and there is no PV and the battery is empty, the grid will support the home load. And this is our operation logic of when the grid failed. The backup load connected to the inverter backup port will be supported by PV power or the battery. So, and we have the UPS level switch time. The switch time is less than 10 milliseconds. That means the backup load will not stop working when the grid is failed. I think it is a very important function in SriLanka because in some area the grid is not stable, and when the grid failed, the PV power and the battery can support the important load in your house. And this is our AC retrofit solution, and this solution is suitable for you have already installed your on-grid inverter maybe 3 years ago, and you want to upgrade this on-grid inverter system to a storage inverter system. And you do not need to remove your on-grid inverter. You just need to add an AC couple inverter. And the working logic is solar power going to the on-grid inverter, and the on-grid inverter is power. The on-grid inverter output is AC, and then we can use our AC couple inverter to charge the battery. Also, during nighttime, the battery will discharge through AC couple inverter to your home load. Okay. And this is another solution of a microgrid solution. Use the AC couple inverter and the on-grid inverter, because if the grid fails, the on-grid inverter cannot working. But when you're using Goodwill AC couple inverter, the on-grid inverter output can connect to the AC couple inverter backup output. Then the on-grid inverter can keep working to support the home load. So it can increase the PV power ratio, use ratio. Also, we have function, for example, the frequency shifting, and the solar power can charge the battery. And also you have the 4-house backup. You do not need to modify the connection of your 4-house load. Okay. And this is our parallel solution of three-phase storage inverter, because the maximum capacity of our ET series is 10 kilowatt. If the customer wants to use the system with, for example, 30 kilowatts, we can parallel 3 ET series and to realize 30 kilowatt storage inverter system. And this is another solution about all-in-one. We have our a 5 kilowatt hybrid inverter, and we have our provide box. Also, we have integrate our battery in the battery bank to consist of 5 kilowatt and 10.8 kilowatt hour hybrid inverter system. As the UI is very beautiful. And we have some other solution, for example, the load monitoring to monitor the load consumption. For example, in a storage inverter system, you need not only the PV production and the power feed to the grid. You also need to know how many power your house have consumed from PV or from grid or from the battery. So the Goodway load monitoring solution can realize this function. And here is some features of Goodway solutions. The first advantage is our one-stop solution. Goodway provide all the components that needed for the system operation. So you do not need to the separate purchasement. For example, we have provided all the terminals that you used, the DC terminal, the AC terminal, and also we have our own smart meter and the CT. Also, we have the Wi-Fi module, Bluetooth module to meet the monitoring function. And this is our UPS level switch time, how we can realize the UPS level switch time. The switch time is less than 10 milliseconds. We have 3 relays, and when the grid is available, the inverter output is go through relay 1, relay 2 to on-grid output and the backup output. So when the grid is available, the inverter have both on-grid output and the backup output. When the grid is outage, the relay 1 and relay 2 is opened and the relay 3 is closed. So the inverter only have the backup output. And the switch time of relay 1, relay 2, and 3 is less than 10 milliseconds. And this is our quick installation and commission. Goodway have provided all the components, so it is very easy to install the storage inverter. So it maybe need half an hour to 45 minutes to finish the installation of Goodway storage inverter. This is our basic commission. You just need to set the safety country, and you need to choose which operation mode. You need to choose, for example, the general mode or the backup mode or the economic mode. And also you need to choose which battery you are using. You are using Goodway battery or other brand, for example, BYD, ALG, or Panasonic. You can choose it in our app. Also, the last step is the meter test. You need to test the meter and the CT installed is correct or not. And this is our 100 unbalanced output, because this inverter is the house using, but if your house is the house grid is 3-phase, but most of the load is single phase, so the consumption of each phase is not the same. So that requires the inverter have the unbalanced output. Like the picture shows, if the L1 consumption is 1 kilowatt and the L2 is 3 kilowatt and L3 is 2 kilowatt, the inverter can output 1 kilowatt, 3 kilowatt, and 2 kilowatt to each phase. So there is no power that feed to the grid. And this is our compatibilities. For low voltage battery, we have Goodway battery and the BYD, LG, Alpha, Panasonic, and Dennis that can choose in Goodway app. For high voltage battery, you can choose Goodway, BYD, Panasonic, LG, and Dennis. And this is our smart control solution. If you want to control the single loads on or off, you can use this load control solution. We can realize when the for example, if you have an EV car, and you want to charge it by PV, and you can set in our app when the PV is enough, you can charge your car. And this is our monitor and the VPP. We have our local monitor by our app PV Master, and also we have provided the Wi-Fi module or the Wi-Fi and the LAN module and the Bluetooth for the monitoring. And we have our local server in Australia, Germany, and Hong Kong. And also we have open API and the data transmission for some customer that they have their own platform. If the customer use Google platform, we have the web platform and the smart apps for our customer to check the working information. Also, we have the Modbus RTU, Modbus TCP, and the SoundSpec protocol have integrate the Goodway storage inverter. So if the customer want to integrate Goodway storage inverter to their own EMS system, we can open our protocol to the customers and it is very convenient for our customer to develop their own EMS system. And this is our smart home system. If the customer have the smart plug and their gateway, they can control Goodway storage inverter working on or not. This is smart home system. This home have installed Goodway storage inverter and the battery. Also, they have their own gateway and the smart plug to control each plug. And I think this topic is very popular, the VPP, and this is the residential VPP solution. And what can Goodway do? Goodway can open our Modbus RTU and Modbus TCP or SoundSpec protocol to the VPP manufacturer to make them to control the Goodway storage inverter to charge or discharge to meet the requirement of the grid. And that's all I want to share to you. And if you want to get more information, you can visit Goodway Solar Community. And there is a platform for our customer to chat each other. Okay, thank you.
Thank you so much, Eric, sir, for such an insightful presentation. Now moving on to our next techno-commercial presentation by Mr. John Wang from J Solar. Welcome, Mr. John, on screen.
Okay, I will make the presentation on behalf of J Solar, and my topic is the high efficiency cell and module solution for PV system. Here are 3 parts of my presentation. The first one is the design idea of Deep Blue 3. The second shall be the technical highlights of Deep Blue 3. And the third part is the value analysis of Deep Blue 3. Okay. As we all know, during the past 10 years, the module power output has been increasing very fast. In the year 2009, the typical module power output is about 290 watts. By the end of last year, okay, I will repeat again. As we all know, during the past 10 years, the module power output has been increasing very fast. In the year 2009, the typical module power output is about 290 watts. By the end of the last year, the peak the peak power of module has already reached 519 watts. Let's review how to approach the module power output. I think mainly from the three issues. The first, cell efficiency. Cell efficiency has increased from 70% in 2009 to about 23.3% in 2022. The second part is about the big wafer. The wafer size has been continuously increased from 125 mm to 182 mm. The third is about the advanced module encapsulation, such as application of coating class, soft ribbon, half-cut seal, and some new technologies such as shingle module paving. All this has contributed to the module power output increasing significantly. And this slide shows the relationship of the BOS cost and the module efficiency. Yeah, you can easily find that when the module efficiency increases, the BOS cost reduced significantly. It seems efficiency contributes more to the BOS cost reduction than the size. And the large module had reached its bottleneck, and the module efficiency increasements shall be considered as a priority for manufacturers. So is the module larger the better? We don't think so. The module set shall has its limitation. When the module continue get bigger, there are no more BOS saving on system size, but will bring higher risk. This slide shows such as mechanical load risk, transportation difficulty, rack bearing ability challenges, and some other problem. In the future, improving power through bigger panel shall be valueless. And so this slide we will discuss about the module current and voltage. High power usually means higher voltage or current. If voltage drops, the current will be increased significantly. Low voltage can add the string capacity and decrease the system cost, but impacts from the large currents on system and the module itself shall be noted. And we have done further research. And this slide shows the higher currents bring higher CTM loss, and which means the production cost will be higher. And also increased currents would result in higher operating temperature, and also the power use will be decreased. And that's more potential risk for connector and junction box deaths. According to Jay's research and third-party reporting, the solar module temperature becomes higher if operating current is higher, which would lead to resistance loss and lower power generation. According to TUV North report, comparing with the larger current module, JSD Blue 3 module, the power generation is more than 1.5% higher, and the LCOE is significantly better. And we think the module shall be determined by the whole industry chain, including production, installation, and transportation, and the solar system configuration. That is our DUB3 module design principle. And last year, JA cooperated with TUV North, conducting 1 year outdoor solar project monitoring plan at National PV Experimental Center in Tri-City, China. We can find that during the high irradiance periods, the average module operation temperature gap between the 182 mm module and the larger current module is about 1.7 degree, and the maximum temperature gap could up to 4 to 5 degree. And the power generation of 182 module is about 1.9% higher than the larger current module. So let's go to the part 2, the technical highlights of Deep Blue 3. We have many 3 module types. The Deep Blue 3 lights, the Deep Blue 3 lights for the mainly for rooftop projects, and the other one, the 72 and 78, for the utilities scale projects. Here is our Deep Blue 3 projects. The key parameters: we use the Persium cell technology and the 11 busbar technology, and the upgraded wafer size, half-cut technology, and the M10 gallium doped wafer. All this bring JD3 a higher reliability and a higher energy use, and also thus lower LCOE. Upgraded PERC technology brings better long wavelength spectral response and low irradiance property, and also low temperature coefficient, low power reduction under high temperature days. The cell and the module substructure are fully upgraded, accompanying with extra 2 to 3% power generation performance. J Solar is the first solar company to deploy gallium doped wafer on all high efficiency cells with IP rights globally. And thus, we have the better degradation and better warranty. And also, this slide we will talk about the multi-busbar technology. J's multi-busbar technology is about the 11 busbar pattern, which will shorter the current transmission distance and lower resistance loss, and enhancing the higher energy yields, reducing the risk of cell cracks and the broken module. Also, 11 busbar ribbons improve optical utilization and with better performance at the oblique resistance. And the half-cut cell technology can getting lower operating temperature and lower hot spot temperature and lower shading loss with better energy yield. Above all, here are the technical parameters. Deep Blue 3 module with reasonable module size and weight, totally compatible with system configuration and convenient for installation and transportation, and bring customer the best LCOE. As for the higher density module encapsulation, JA also launched its patent gapless flexible interconnection technology, integrated with flexible interconnection buffer treatments, optimize the encapsulation material, avoiding the micro cracks issues at the cell interconnection, higher module reliability and production stability. And the third part shall be the value analysis of Deep Blue 3. We have done some demonstration projects analysis. We select a project in Dubai, 1 megawatts. Deep Blue 3 could bring the customer with 5% to 7% LCOE reduction benefits. This including the rack usage, inverter cost, construction cost, cabling cost, and landing cost reduction. All this bring better LCOE performance. And this slide shows further BOS reduction details. We can see that Steel Blue 3 could bring a 2% BOS reduction cost benefits. Okay, that's all for my presentation. Thank you.
Thank you so much, sir, for such an insightful presentation and for setting the tone for our panel discussion. So now it's time to begin with our most awaited panel discussion, which is on energy storage market outlook Sri Lanka. And to discuss this, we have in the panel with us Mr. Romelo Peters from Powit Solar Lanka Private Limited. He will also be the moderator for this session. Mr. James Ho from Goodwill, Mr. Supun Pereira from Events PLC, Mr. Daniel Lee from JA Solar, and Mr. John Wang from JA Solar. The session will be led by Romelo sir, and I would request all our panelists on the screen, and I hand over the screen to Romelo sir to take it forward.
How is GA modules compatible with inverter? And then how will ESS will help current grid reliability?
Yes, okay. Romano, our technical manager, John, he will give you answer.
Okay, hello, Romano. Can you hear me now?
Hi, Juan. How are you? So
Yeah,
just want to
I'm
ask
fine.
you, how ES will help this current grid reliability and overcoming the challenges from Goodway. How will the GA modules be compatible?
Yeah, JA Solar has comprehensively evaluates with the compatibility of the module and with the inverters. A Deep Blue 3 module are designed based on the M10 wafer, which is the 182 millimeter wafers, and working at a current of the 13 ampere, which is within the MPPT input current of inverter. Thus, JD Blue modules are perfectly compatible with the inverter and the optimizer, and ideal for the PV system application. Harron's current module, based on the larger wafer, may face the issue that there are no available inverter matched for. That is about the problem with the compatibility with with inverters.
I'd like to ask a question to James. I would like to ask about how ESS will help in the current grid reliability and overcoming over the challenges. So I would like to put some light on this, James sir.
Yeah, okay. Twinkle, can you hear me? Hello? Am I
Yes,
audible?
I can hear you.
Okay. Yeah, talking
Yes, sir, you
about
are.
the ESS to help with the grid reliability. Majorly it's about the ESS will help to do the peak saving, right? Which will help the grid to cope with peak demand. So specifically, the battery will charge power from the grid, or from the solar, or from the grid, right, during peak hours. So and discharge the energy stored in the battery to power the loads in peak hours. So pressure on grid will be reduced. So that is a major part. And also the ESS can also provide backup power during blackouts. So emergency facility can still keep running. And the third point will be even the ESS can help to create a microgrid when there is no grid. So the grid tie solar system that we have already installed can still be running. So it will be very useful for areas like islands, some remote areas without grid connection. So this is also very popular applications nowadays. So yeah, the 3 points pretty much cover this question. Back to you, Twinkle.
Okay, so one more question I would like to ask about, like, what do you think are the suitable applications of this technology, sir?
Talking about the hybrid system, energy storage system here, actually, the typical application would be in two scenarios. First one, that is the classic one, the typical hybrid inverter. First is the solar panels will connect to the hybrid inverter and to feed in the solar generation also. And the inverter will be connected with the house load as well as grid. So, I mean, basically, the hybrid inverter will work as the brain to manage the whole system, right? About the conversion of the power and also manage the allocation of the power into the load or the grid with different purposes. So that is the first scenario. That is a hybrid inverter solution. The other one would be the retrofit. So which means you already have the on-grid solar system installed, right? So now the uh, the application like habit changed or the policy changed, so you have to you need to put a battery into the system, right, to turn that system into the energy storage. Then you put this retrofit device to transform the whole system into energy storage. So that will need the product we have here, uh, the AC coupling device. So that will connect to the inverter, on-grid inverter. Then you can take battery. So then the whole system will have the energy storage feature. So that is that. Those are the two very typical scenarios for this energy storage application. Twinkle.
What are the unique advantages of deep blue? I just want to understand this from you.
Yeah, regarding to the deep blue unique advantages, I think that there are many advantages. The first is our like guarantee for the degradation. And J Solar is the first solar company deploy gallium wafer on all high efficiency cells. So we give the better warranty, the 2% in the 2% degradation in the first year, and also the better energy yields. For example, the low that energy yields and the high temperature power generation. Also, according to the third-party reports, JD Blue 3, JD Blue 3, the power generation is about 1.5% higher than the larger current module or other module types. And the third one, I think, is the reliability. Uh, yeah, as we know, we give the 25-year power output warranty for the monofacial module and 13 years for the bifacial modules. And also a deep blue 3 with the reasonable size and the weight suitable for the installation, transportation, and also can bring can bring out the shipment cost reduction. And the first one I think shall be the LCOE. Yeah. Okay. Yeah. Above all the JD Blue 3 technical parameters, JD Blue 3 bring the about 2% both reduction and 5 to 7% LCOE benefits compared with uh, the 105 module and the 106 6 millimeter module. I think basically that is about the advantages of deep blue.
How ESS will help in current grid reliability and overcoming other challenges?
Okay. So basically, unlike on-grid systems where solar will depend basically when there is sunlight, and whenever there are clouds, the potential of solar reduces. So that causes a grid instability. By having ESS systems with battery backups are always, it produces constant power. So ESS systems in a nutshell will produce grid stability rather than having only the solar system that side which are produced that will cause stability when there are clouds. But with battery backup systems, since the power is always constant, it will always produce a constant power to the grid. And this also, in turn, this will also help the industries and the domestic entity to produce power, reliable power to the grid, as well as saving money in long term in Sri Lanka. Because what happens is, if they charge during the night, when the power is cheap, charge the batteries at night, in long term, according to our calculation, each household will be saving approximately 6,800 rupees. So there are advantages to using ESS systems as well, and that amount in the period of 7 years will help to pay off for the battery, because the batteries are the biggest issue right now regarding cost. So if you calculate that saving for 7 years, you have saved about approximately 150,000, and that will go towards the cost. So that will also help to overcome the current issues regarding cost and reliability. Okay, like I was saying, uh, ESS systems will help to produce constant power, unlike having an on-grid system where the power generation will depend upon the sunlight. Whenever it's cloudy, there won't be power. There will be less power, so it will cause a grid instability. By using ESS systems, it will produce constant power to the grid, and that will cause grid
What are the challenges and benefits of behind the meter storage?
industry. Basically, I will start with the challenges. Challenges are the high costs of storage systems. The battery cost is extremely high, and if you calculate, uh, uh, there isn't any long term benefit. There is only short term benefit. But but thankfully our country has switched to the daytime tariff systems, where you pay a certain amount depending on the time. So by using that, Sri Lankans can benefit using the battery systems by getting the batteries charged at night time, between 10:30 to 3 a.m. So if we can use a ESS system uh, to automatically charge the batteries during that time, there'll be a long-term saving. So that is on the advantages side, and the disadvantages are, at the moment we are facing, only disadvantage is the high cost of the batteries.
Okay. James, sir, would you like to throw some light over here on this question? Like, what are the challenges and benefits of behind the meter storage?
Uh, like Romelo said, the challenges will be, yeah. So people's understanding of including the energy storage into the system. actually now we are so used to the application of a grid-type solar system. But as we can see from other markets also, it's not started with Sri Lanka market in a big scale. Actually, in other markets, we've already seen this trend. People are taking energy storage into the solar system uh, in a big way, actually. So I do believe that it will gain the popularity in Sri Lanka as well very soon. And but yeah, every actually from every point of the chain, we're trying to reduce the cost for energy storage because that has been the hurdle for this application to scale up. Uh, Now, over the past few years, we've seen this has been achieved in a good direction actually. So the cost
Okay, and
has will be, I mean, but I would say the trend, right? Like, I mean, these 2 years are totally different as the years before. So, like, I would say almost 20 to 30% of the projects are thinking of using storage also. So this percentage has increased a lot over the past 2 years. So we're seeing this trend going on also. So in the years to come, definitely the percentage of using energy storage will still be increased. And so this is a trend. The challenge, the cost will be the hurdle, but now we've achieved something very impressive, right? To reduce, to bring down the cost. So it is in the right direction. That is good. Uh, and about the benefits, definitely to help to stabilize the grid, right? So if you talk to the grid companies, they will be very happy, right, to see energy storage is thinking is being considered in a big way, right, for the solar system. I mean, like, if you ask me, I would say Thailand is a typical place because the grid company has talked to us many times about uh, introducing the energy storage technology into their systems because that will help to avoid uh, like their painful point is that they have to, because now the energy assumption, right, has increased a lot, so their original electricity facilities cannot afford that, cannot is not enough to support that. So they have to upgrade their electricity facility, but that will cost huge, hugely, right? So they're looking at uh, getting the support from energy storage system because that, again, that's about peak shaving. So I mean, when the demand of power comes up in peak hours, so they can use the energy storage system to help reduce the pressure from the grid. So this will be a very big topic if electricity companies. So that will be the biggest benefit I want to come to. Twinkle.
how to achieve this levelized cost of rooftop energy storage system?
That will be in two aspects actually. So first about the supply cost of the system, right? So him to bring down the material cost for sure. So battery, right? The inverter, the solar modules. So now I think the major focus has been put on the battery now. So battery price over the past few years has been increasing all the time. Uh, on the contrary, I mean, module again sometimes increase, sometimes going down. So we would say stabilized. Inverter still okay, but the battery price just increased too much. So we still need to work more, right, to bring down the system cost to make it more effective to install the energy storage system compared to the grid tie system. And so yeah, and after you install, because you should also look at this question from the another angle, that after you install the energy storage system, you will see your electricity bill, right, being reduced. Right? So that could be considered as the save on your cost also. So if you look at different countries, the scenario will be after people installing this system, so the electricity bill, right, will be reduced in a big way. And but Sri Lanka, we have heard that they considering uh, uh, like depreciate the electricity price for peak hours and off peak hours. So that will be very significant to move there, because I mean all the other countries who are very popular with energy storage installations, so they will have different prices for peak hours and off peak hours. So that would be the driving force for the popular use of energy storage, and also when the grid is not stable, right? I mean, a lot of blackouts or whatever. So then the importance of energy storage will be seen also. And I mean, I believe that is what happening now in Sri Lanka. So a lot of blackouts, and so customers, because that we heard it from our customers also, right? So they're in urgent demand for the energy storage system.
Yeah, I just like to know that what is the need for hybrid energy storage solutions to meet the requirements of different rooftop energy segments, sir?
Uh, you mean the module, the system with hydro inverter, right?
Yes, sir. Yes, sir.
Like John says that for module, actually it's a bit simple, and not like one system or inverter or hydro inverter. So our modules can match whatever hydro inverter or some hydro inverter or other ESS. This is no problem. From our side, we may consider the thing is that firstly, the project is, I mean, for how many hours they need for output, or if they consider ESS, and also what will be the cost, and how many years it can take back the invest. And so for module side, I think there's no more request. We are standard product.
Okay, sir. Sir, any final remarks that any one of you would like to make? James, sir, Romello, sir, Daniel, sir, John, sir. Any final remarks that you'd like to?
Let me see first. Thank you. Well, we know now in Sri Lanka market, the electrical almost cut down per day more than 7 hours. And yesterday, one of my friends told me the electrical cut down around 13 hours, and it's very unstable. So based on today's webinar, I think this is a good chance and opportunity to showing to the market and the Sri Lanka, and let them to know both JA Solar and Goodway, whatever from Goodway's inverter or ESS, those products can match together very well. And also we have reference on the market, whatever Sri Lanka market or other market, whatever for rooftop or whatever for the solar farm. We already covered it together, and we have very good data. And later, any clients or anyone who are interested on that, both James, Goodway, and JA Solar, we can share more data and more details to them. And also, we can give the solution, the system solution to them, to help the market to enjoy the life because we need the lights. Uh, we need the electrical. So I hope this webinar can let the market know the renewable energy very well and know J and Goodwill very well. And then we can give the best support. And we also wanted to do something, do some contribution to these lovely countries and to the nice, kindly persons, people. Yes. Yeah, James.
Yeah, okay, Daniel. Yeah, thank you for that. Right, the warm words.
Mm.
Yeah. So nothing from my side actually. Yeah.
Well said, Daniel, sir. And I think in spite of this power crisis, we had many audiences joining with us. I would really like to thank all the audience and attendees who have tried to join us from Sri Lanka. Also, we would have missed many of our speakers due to the power crisis, but nevertheless, thank you so much, all the esteemed panelists, for this wonderful session. And with this, we have come to the end of the webinar. I would really like to thank all the attendees for joining us today, and we promise you to come back soon for more exciting topics. Till then, bye from my end, and now the floor is open for networking. Thank you so much, sir.